All right, the Pythagorean Theorem. Why is it named the Pythagorean Theorem? The dude's name was Pythagoras. He lived in Greece. Greece was a place that was very heavily involved in war and conflict. And it was back in the Renaissance time period when all these kinds of ideas were really being discovered, and mathematics was, just the beauty of mathematics was being studied almost as, not a religion per se, but as a very highly interested area. And things that we take for granted, like this formula, were just being discovered. It was really cool. Well, the guy's name was Pythagoras. He discovered it. He actually had a number of disciples, much like Jesus did or Paul did or things like that. And back then, the only way you could get an education was to attach yourself to a learned man and study under him. Now, Pythagoras not only was a mathematician, he also was a philosopher and a number of other things. But he came up with this theorem. And his disciples protected him to the point where they would sacrifice their own lives to protect him. At one point, Greece was attacked. He was in his, they had a kind of a house surrounded by a wall, and they farmed around it. And the soldiers are at the gate trying to break in to take them into captivity and things like that. His disciples go to the gate, fight the soldiers. Pythagoras gets out of the back of his house, escapes across the back of the bean field, and ends up living. So, back then, just like Jesus had disciples, Pythagoras did as well. But this is one of the things that he came up with in terms of phenomenal, great ideas and concepts. A squared plus b squared equals c squared. That's how we know it now. You've all done it before, I would assume. But what it says is when you have a right triangle, the hypotenuse squared is the equal to the sum of the two sides squared. Now, what does this little square in the corner mean?
It's a right angle.
Okay, that means it's a right angle. And what else also do we know about a triangle? What do the angles add up to? Okay, the angles add up to 180. That's just a good common number to know. The angles add up to 180. So, if we square the two short sides, add them together, that should equal the long side squared. So here we go. All we're going to be doing today is trying to find the missing sides of triangles, but in many cases we're going to have to end up getting our answers in simplified radical form, not decimals. So, let's take a look. Sometimes decimals will be nice and we'll use them, sometimes they won't. I'm giving you A, I'm giving you B, I ask you to find C. Just to give you a visual, that's 5, that's 12, that's C. All right, the C is always across from the right angle. So all I'm going to do to figure this out, I'm going to say 5 squared plus 12 squared equals C squared, 25 plus 144 equals C squared. That's 169. And what did we learn last chapter? How do you solve C squared equals a number? Take what to both sides? Square to both sides. So C equals plus or minus 13. Which one am I going to throw out? The minus, because we're talking distance. So in this case, your answer is just 13. Okay? You do have two answers, but we have to throw one out because we're talking distance. Now that's a pretty straightforward one. We can do it in our heads. The next one we're going to need our calculators. 7.4 squared plus 3.2 squared equals C squared. Someone crunch this out for me. If you don't have your calculator already, get it out. If you need to borrow one, come on up here. What's 7.4 squared?
54.77.
We'll see one. How much is it? 54 point what? 54.76. What's your question, Kyle?
When you took out the negative 13, will it always be the negative?
Yeah. You're always going to throw out the negative because you can't have negative distance.
Why do you have the plus or minus?
Because when you take the square root of both sides, you have two answers. True? Would you agree that 13 squared equals 169 and negative 13 squared equals 169? Okay, that's why.
Why are you taking the square root though?
Because you have C squared.
Oh,
You got to get rid of the square. What's 3.2 squared? Somebody else? 10.24. Add them together.
65.
Conveniently 65. What a coincidence. Take the square root of both sides. What does C equal? 8.06 what?
225.
Okay. Now, let's talk about, I'm going to change this equal sign to a squiggles. What does a squiggly mean? Approximately. The problem gave us estimation starting with tenths. So if it starts us in tenths, Luke, we should respond with tenths. So round this to the nearest tenth. What would we say then? 8.1 is approximately the value of C. Why did I go to tenths? Because they gave us tenths. All right, moving down. Find the missing side of the right triangle. What are you missing?
B.
B. So here's our equation. 15 squared plus B squared equals 17 squared. You know this in your head. What's 15 squared? 225. Somebody else, what's 17 squared? Good. How do I solve this?
Subtract.
All right, subtract 225 from both sides. B squared equals 464. So what's my value of B? 8. Terry, am I going too fast? Are we okay? All right. Next one. What are we missing?
A.
Okay, so A squared plus 24 squared equals 25 squared. Work that one out on your own, see what you get. A squared plus 24 squared equals 25 squared. Somebody else can do that today? Justin, you need one? You have one. Good answer. Raise your hand. Come check. Yep. Hold on. What do we get here? Good. Lost it. Nice. All right, I see most of you are getting the answer of 7. 24 squared was 576, 625. We subtract. A squared equals 49. We take the square root and get 7. All right, flipper. Pythagoras also then gave the converse of the theorem, the reverse. He said, if the sides squared add up to the hypotenuse squared, then the triangle is a right triangle. Does that make sense? If it's true, then it's right. So let's see. Do these three sides make up a right triangle? 11 squared, 13 squared, 18 squared, 121, 169, 324. Is 9 plus 1 a 4? So without even adding them up completely, what can I say? No. All right? They are not a right triangle because it's not equal. Let's check this next one. 10 squared, 24 squared equals 26 squared. 100. Do you know in your head 24 squared?
576.
Good. 576 equals 676. Just taught you a new square there. Is it true? It is. So what does that tell us about these three sides? They are a right triangle. Okay? What about 7 and 8? Let's look at 7. Let's just use some common sense here. Here's a leg, length 4. Here's another leg, length 4. Here's a leg, length 8. Think with me, folks. Can you make a triangle out of 4, 4, and 8? Why not? First of all, is it even a triangle? You can't even make a triangle, much less a what? Much less a right triangle. Does that make sense? If I have two sticks that are 4 length long, and I'm trying to make a triangle out of them, I can't connect it to an 8 and make any kind of an angle. What if it was 4, 5, 8? Would that make a triangle? Yeah, but not 4, 4, 8. You could prove it, obviously, the right triangle piece. Obviously, 4 squared plus 4 squared is not 8 squared. So either way, either with common sense or with algebra, we can show that. All right, last one.
Yes.
You think yes? Is 9 squared plus 40 squared equal to 41 squared? 81, 1600. I need some help here.
1689.
It is? So that is true. Wow. That's a pretty big right triangle. Perspective-wise, you know, that looks like this. You know, that's a very narrow right triangle. This makes sense? Pretty doable? What do we got down here? 1 through 19.